Lab 5. Choose your own adventure. The order of this presentation will be first introduction, which includes purpose, the steps followed, the model chosen, and the results. Second, an explanation, which will cover an overview of the code and an overview of the graphs obtained. And finally, the conclusion, which includes the errors and the reasons behind them. So the purpose of this experiment was to choose any system of our interest to investigate and model that was related to the physics principles learned during the course. The steps that I followed were: I obtained real data from the video I chose, used a physics model to predict an aspect observed in the video, and finally I used VPython to model it. The model that I chose was of a man jumping off of a roof. The results that I got were that although the graphs for the position in the X and Y direction have the same shape, the code predicts it will move farther in the Y direction than reality. Second, the energy curves for the code follow the conservation of energy principle, but the actual video doesn't seem to do so. This is the video that I chose. Like I said, it is of a man jumping off a roof doing a flip in the air. The origin that I chose was when he started at the top of the roof and then he moved downward. Now let's take a look at the code. For this first window, it's just a setup of the information and the screens that I needed for my program. I calculated or estimated the mass of the person to be 70 kilograms. I say estimate because I don't actually know the mass of the person. I know that my gravity constant is 9.8, and this is the drag force constant that I tried to calculate. My initial position, as I said, is the origin of my video, and the velocity that I estimated was using the slopes of the change in position of the information I got from Tracker. Then I have my time step and this data, which is just to export my data out to Excel. And then here I calculated my kinetic and potential energy, which were 1/2 times the mass of the person times the velocity squared, and the mass of the person times the gravity times the height, which is just the position in the Y direction. Here I have my while loop, which is where I actually use physics equations to calculate information. So to calculate my net force, I have my force from the feet, which is an estimate that I made of the impulse that the person needed to jump off of the roof, the drag force, which I also estimated, and the gravity, which I know that is negative the mass of the person times the gravity constant. I used Newton's second law to calculate the new velocity, and then use that information to calculate the new position. Afterwards, I also updated the kinetic and potential energy and found the difference between each step in energy to be able to graph my information. Here is just some information that I needed to be able to export my data again. So the overview of the graphs is the following. For my X position versus time graph, I got that they were pretty similar, and that the error that was obtained could be due just to experimental error. But the Y position versus time were really different in the sense that the code estimated the object, well, in this case the person, to fall a farther distance than it actually did. Now for the energies. So the code graph that I got for the change in energies actually did follow the conservation of energy in the sense that as the kinetic energy increased, the potential energy decreased, and if you sum both of them, then you get a constant line of zero energy, which means that no energy exited or entered the system. But the experimental energy changes actually didn't follow any pattern. The total energy followed the same shape as the kinetic energy, but was down in the level of the potential energy. So this information was very confusing, and it might have been due to the lack of some information. So the conclusion that I got were that although the X direction prediction was relatively accurate, the Y position was not. The reason for this is the lack of tools to know the amount of force used to push himself off the roof, and the inaccuracy of the calculation of the drag force that was applied on the man. The energy graphs of the video didn't show any sign of energy conservation of energy. This could be due to how the video was analyzed, in the sense that the time frames may not have been small enough, or the lack of knowledge of accurate measurements, such as the height of the man, the weight of the man, and the movement of the video in general. This was my Lab 5. Thanks for watching.